Let's look at this question. The gate AB, there's a gate AB, is located at the end of 6 feet wide water channel. The channel, this is a water. The 10 feet is water. The width, you can see it, if you look at from here, it is 6 feet deep that way, 10 feet high. And if you look from this side, if you are sitting down here, you can see that the depth is 6 feet down inside the computer. So 6 feet wide water channel, and is supported by hinges along the top edge A. So there is a hinge here, A, which means that there is AX and there is AY. Knowing that the floor of the channel is frictionless, determine the reaction at A and B. So the floor is frictionless, there's no friction, but there is a reaction, normal force at point B. Let's look at this dimensions. Now, the water will have a force on this gate. So the water will have a force. The way we do this is by going from zero pressure or zero force, pressure force. We do it like this. This is the gate. Remember, we have AX, we have AY, and we have the reaction BY here, B. And the way we do this water is by starting, of course, we have to distribute this. We have to have a triangle water here. And we're going to find out later on the weight of this triangle. And we should start from a straight line, start from a zero pressure, force pressure, all the way increasing linearly to get pressure max. Because if you swim, every time you go deep, the pressure force would be higher. So you'd expect at top of the water, the pressure is atmospheric, not that much pressure, zero. And every time you go swim, down, pressure will increase to a maximum pressure point B. So this pressure is a triangle, 0 to a maximum pressure B. The location of the centroid of the equivalent pressure is P, pressure B. It's 1/3, and this is 10. So 1/3 a 10, which is 10 over 3 feet from this side, the centroid. And the location of the centroid from this side is 2/3 10. 1/3 10 from here is 10 over 3, and 2/3 10 from here is 20 over 3. Now, since the pressure distribution acts like a triangle, there's something missing here. This small triangle of water. It's a triangle. We can see that it's a 3 feet from here. It's a 3 feet from here. So we could take it 1/3 of a 3. 1/3 of a 3 from the corner here is 1, and 2 from here, because it's 3 feet total. So now let's find out the pressure. The pressure B, the maximum pressure here. Let's find out the maximum pressure here. Pressure B. So if you apply the equation of the pressure, which is 1/2 A times gamma times H. What is the area here? Of course, the area is the width. Remember, I was saying that the width of this channel deep into the paper, it's 6 feet. And what is the height? You can see the height is 6 plus 4, 10 feet. So the height of the water is 10 feet. So 1/2 BH times gamma times H. So 1/2, 6, the depth, times 10, the height, times gamma. Gamma this is gamma for water, pound per feet cube. This is fixed. It's a standard, 62.4 pound per feet cube, time 10, because it is 1/2 to find the pressure, times area, times gamma, times H. So the pressure at B is 18720 pound. So we found the pressure at B. Now, let's find the weight of the water. The weight of the water, we mean this weight. You can see it's still a triangle, and we should apply the same phenomena. Gamma volume to find the weight. So this equation should be given. Gamma volume. Gamma is known 62.4 pound per feet cube. Volume is 1/2 WH times B. Remember, it's a triangle. 1/2 W, the weight, H times B. Now, first of all, you can see that this triangle is 1/2, 3 times 6. 3 times 6. 1/2. 3 times 6 times the depth inside, which is 6 feet, because the depth of the water inside the paper is 6 feet. So 1/2, 3 times 6 times 6, this is 3,369.6 pound. This is the weight of this triangle of water. We found this force. We know the location of this force. It's 1/3 from here, 1/3 over 3. It's 1 feet from here and 2 from here, because the whole thing is 3 feet. So we found this. Now, what to do? The best is to find moment at point 8, so you could cancel out AX and AY. You can see that this W, which is the 3,369.6, around A, it's gonna go like this, positive times 2. 3,369.61 times 2 in the plus. And also, what's the other force? This force, P. P times what? This is the perpendicular distance, 20 over 3. Okay, so P, that's going to be positive. B, which is what? 18,720 pounds. Times what? Times 20 over 3 in the plus. Remember, moment at A, this By will move the things around it like negative. By times 3. And that's negative. Minus By times 3. You will end up with By is equal to 43,846.40 pounds. So now we found By. From this, you could find By. You could do summation of force in the y-axis to find Ay. Of course, there's nothing else other than the weight and the Ay. So Ay minus the weight and the forces and the x-axis, the weight is this. Okay? By plus Ay minus the W, that's in the x-axis. Okay? To find out Ay. Okay? Because as we said, it's Ay minus W plus By. So you'll get that Ay is equal minus 40,476.79 pounds. What is the meaning of minus? It would mean that the Ay is opposite in direction. Ay is not going up, it's going down. Let's find summation of forces in the x. We want to find Ax. This is y, this is y, this is y. So Ax and B should be in this calculation. Summation of forces of x equal to 0. This, you could put B in the plus Ax equal to 0. Ax would give you minus 118,720 pounds. Now, which means that the Ax is not in the positive x, is going back in the negative x. Let's find the resultant of the forces for the A by doing A square root of Ax squared plus Ay squared. You just put the Ax squared and Ay squared and you will get A as equal to 44,596.06 pounds. and the resultant force is that much for A, and then you could find the angle of that force. Theta is equal to tan inverse AY over AX. You just put AY over AX, tan inverse of that, you'll get 65.15 degrees. That is the resultant force that takes that angle. Thank you very much.